we're going to talk about the orthocenter, which is the point of intersection of the three altitudes, which are the heights. A line from the vertice and perpendicular to the opposite side. That's what an altitude is. So as you can see, I've used the same triangles we've used to find the orthocenter and the centroid. And I can draw from the vertice to the opposite side a 90-degree angled line. Okay? And then I'll do the same thing here. I mean, it's not very, I'm just using it by just looking at it. It's not going to be exact, but just to show you what it is. So here we go. Okay. And so there it is again, and this is at 90 degrees. And then I take the last one, and what I want to do is make it about 90 degrees. And there we have it. And so this is the point I'm looking for. Okay, another point of intersection, which means we have to solve a system of equations, which means we have to create our equations. Now, one thing we already knew is the different slopes of these lines. We've already done that. And so the perpendicular to this line is this one here. So perpendicular slope of this one is going to be 1/2. For this line here, okay, which is going to be m perpendicular is going to be 5/2. Okay. And then for this one here, that's perpendicular to that one, this line here, I'll put it over here. This line perpendicular to this is going to be -3/2. And so now to find the equation of the line, I have a slope and I have a point. This one. I have a slope and a point. I have a slope and a point. And so that's what I'm going to use to find the equations of the lines. Now we've done this several times. I will just go over it once just to refresh your memory. And so we can use, we can start by trying to find this perpendicular bisector. So we have A is -4, 1, and we have the slope of this one here, which is 1/2. Okay, and so to find the equation of the line, again, y equals mx plus b, and we've got an x, a y, and the m, so 1 is equal to 1/2 x -4 plus b. Now remember, we've already solved for these from previous videos, and that's why I'm not redoing the same thing again. You can look at them on the previous video on circumcenter and centroid to find out how we got slope. Okay, and so we have got 1 is equal to -4/2 plus b. Bring that over, that's 2/2 plus 4/2 is equal to b, so b is equal to 6/2, b is equal to 3. And so I've got my slope, I've got my y-intercept, y is equal to 1/2 x plus 3. That's one of my equations. And if I look at this, the first one that I did, 1/2 x, this is, again, I just drew it without great accuracy. But this supposedly should go right through 3. I've got 1, 2, 3, almost. So it's hard to really make a perpendicular by looking at it. So you really have to do it algebraically. And so there we have our first line, which is this one here. Y is equal to 1/2 x plus 3. And then I do the same thing using slope and a vertices, slope and the vertices for the others. And so I will write down for you the equations. That second equation I've gotten is y is equal to -3/2 x plus 6. And what I'm going to do with this one is I'm going to find the point of intersection of this one here by using substitution or elimination. And we've been doing substitution, so why don't we just continue with that? So using these two, I can then work at them here. So y is equal to y. 1/2 x plus 3 is equal to negative 3 over 2x plus 6. Bring that over. 1/2 x plus 3 over 2x is equal to 6 minus 3. And this gives you 4x over 2 is equal to 3. And what you do here is you're going to, when you divide, you multiply by the reciprocal. So 3 times 2 over 4. Really, I could have, 4 over 2 is 2. We could do that much easier. And then that would be times 1/2. X is equal to 3 over 2. Sometimes things look really easy and you can't see them. And so this is my x value. And now I can just plug this into either one of these. And so I can just plug it into this one here. Okay. So y is equal to negative 3 over 2 times 3 over 2 plus 6. Y is equal to negative 9 over 4 plus 6. And so what we want to do now is find our common denominator, 9 over 4. And this is going to be 24 over 4. And then finally, y is equal to 15 over 4. And so we have our x and our y, and this is our POI. Okay, so the POI that we found is 3 over 2 and 15 over 4. Now the key here is to make sure that this will work with their third equation. Okay, and the third equation, doing the same thing as finding the point and using the perpendicular. The third equation that we found is y equals 5 over 2x. This is the third perpendicular bisector. And to find this, I had used the slope, perpendicular slope 5 over 2 and the point 0.25. Okay? So, and this is the equation I got. So now let's plug this in and see what we get. That's 5 over 2, 50, and x is 3 over 2. And y is then equal to 15 over 4. And it works. There it is. And let's look at it on our diagram and see if we were pretty close. 3 over 2 is like 1.5. So 1.5 is here. So that's very good. And 15 over 4 is almost 4. 1, 2, 3, 4. I mean, I'm off a bit, but that's approximately, from my drawing, 3 over 2, 15 over 4. And so for the orthocenter, we have found the perpendicular bisectors. The perpendiculars. The altitudes are just perpendicular to the opposite side. Perpendicular bisectors is when you're looking for the circumcenter. And so from the vertex or the vertice, you go down this way and this way and this way. You find your equation of the line by using the negative reciprocal of this slope and this point and do it all around. And then you use elimination or substitution, get your point of intersection, use your last equation to check. And that's how you find the orthocenter.